Hi Satsters, what we're going to do in this video is look over speed and acceleration calculations. I'm going to use this Jamboard here, okay, and I'm going to just talk you through how I would go about attacking these questions. These are very similar to the ones that you've got in your worksheet, but obviously I've changed some of the parameters and the numbers so that you can apply them without getting the answers given to you. Okay, so in this one we're going to calculate speed. Okay, so the first thing we need to be comfortable with is that speed is equal to distance divided by time. Okay, so that's the first thing we need to be comfortable with. So it tells us that Steve is cycling down 10th Street. He travels 250 meters in 45 seconds, assuming he does not speed up or slow down. So what we're saying there is that this is a uniform motion. Okay, hopefully we remember that. What is his speed in meters per second? Okay, so the first thing we need to be comfortable with here is that we have a distance. Okay, so there's D, and we have a time, so there's T, and this is as simple as going speed is distance over time. So show your workings where you can. 250 divided by 45. Okay, you are welcome at this point to use a calculator. Okay, there's no reason not to. Okay, if you can do that in your head, you're absolutely welcome to do so. So 250 divided by 45 is 5.6 meters per second. Okay, and that's the answer to that one. What you might find in some questions is that it might give you a distance and a speed, and it asks you to calculate a time. What you can do with this formula is you can put it into a triangle. Okay, so speed, distance, time, and you can turn it into a triangle like so. Okay, and what the triangle tells you is that distance on the top is always divided by either of the things below it, depending on what you know. So it depends on the question. And then there's a multiplication in here. Okay, now, if, for example, you want to calculate the time because you know the distance and the speed, you can cover up this this one. So let's not make it transparent. Let's make it white. No, it's not going to work. So we cover up time. So what that means is that time is equal to distance divided by speed. Okay. If we want to know distance, then distance is speed times time. Okay, so you'll just need to rearrange that formula to suit the parameters of the question that you're given. Okay, right, moving on. Displacement questions. So you might get some questions where it will give you some information and you may need to work a displacement. Now, what we understand is displacement gives us a direction. So an object could move 10 meters to here, but then it might move back 5 meters, okay, to here. Its actual displacement in that particular case is only 5 meters. All right, so that's the actual displacement. So this is what we need to consider with this next question. So it tells us that Sam's walking to a friend's house. So again, this is very similar to the question you've got. It's not the same. We've changed the names, changed the numbers, so you can apply this information to your question. She walks 800 meters to the south. She then realizes she walked too far. She turns around and walks 350 meters north. The entire walk takes 120 seconds. What is her speed per second? Now, the first thing we need to be comfortable with, if we're going to calculate speed, is we just need to know the distance. Okay, so speed considers the entire distance traveled divided by the time. So in this case, if we call this part A, okay, so part A works out the total distance. So that's going to be 800 plus 350 divided by 120. Okay, so what we've done there is we've added together this distance here to this distance here, because what this is telling us is that Sam has traveled 800 meters in one direction. I know it's to the south, but if we just assume that this is south, she's then turned back and traveled 350 meters back to here. So that is the total distance traveled. okay, in this particular case. Now, what that tells us then is a speed. Okay, so this is an average speed for that particular journey. So that's going to be 1,150 divided by 120, which gives us 9.6 meters per second. And all we're doing there is we're just rounding to one decimal place. Okay, so that's part A complete. Now part B, I'm going to do in green. Part B asks you to calculate the velocity. Now velocity is different because velocity, so for B, velocity is displacement over time. Now displacement is different. What we did up here is we talked about an object that moved 10 meters and then 5 meters back. Now its displacement was 5 meters. So although it went up and back, what we should be comfortable with is it's actually only moved 5 meters in terms of its displacement. Okay, and we can see this in the question. So we saw that Sam walked and then came back. So the displacement is actually this bit. So it's the difference between the two. So in this case, what we will do is we'll take the 800 meters to the south and we'll take away the 350 meters to the north. We'll then divide that by 120. And this will give us a different figure. Okay, so 800 minus 350 is our first step. And again, we should probably put that in a bracket like so. So 850 minus, 800 minus 350 is 450. Again, you can probably do that in your heads. If you can, then that's great. If not, use a calculator. Divided by 120, that's 3.75 meters per second. So what we can actually see is if we're calculating an average speed, an average speed, sorry, then it's going to be slightly higher. So this is the average. Let's spell that right, shall we? It's probably best to spell that correctly. Average speed, and then this one is a velocity. It's an average velocity but it takes into account the fact that Sam came back on herself. Okay, so that's displacement questions. The last type of question you're going to get is all about acceleration. Okay, now what we need to be comfortable with acceleration is that acceleration A is equal to the change in velocity divided by the time. Now, the way we can denote this, it's important to note that the change in velocity is essentially equal to the end velocity minus the start velocity divided by time. Okay, and what this gives us essentially is a formula that I'm going to write down at the bottom. A is equal to V take U over T. Okay, in this particular example, what we'll find is that V is the end velocity, U is the start velocity, and T is time. Now you can't stick this in a triangle; it doesn't work. All right, but what you will be able to do is rearrange this formula to calculate any of those bits and pieces, and I'll talk you through that in a minute. Now let's work out this question first. Okay, so the roller coaster velocity at the top of a hill is 8 meters per second. 3 seconds later, it reaches the bottom of a hill, a velocity of 35 meters per second. So you've got all the parameters you need. You've got a start velocity, you've got a time, and you've got an end velocity. So all the three things that you need to do to calculate acceleration. Okay, don't be afraid to write on the questions like this. I find it helps me to circle the parameters that I'm going to be working with. So A is equal to, so we want the end velocity, so that's 35, that's the velocity it finished up at in the question, minus the start velocity, which is 8, and then divide it by the time, which is 3. And again, all you're doing is calculating each of these stages. So 35 minus 8. So the change in velocity is 27 meters per second, and it took 3 seconds to do it. So you divide that, and that gives you 9 meters per second squared. So that's the acceleration of that particular object. Okay. Now, in certain cases, you might get a question that might give you a situation where an object slows down. Now, you don't change the way you work this. So say it went then from 35 meters per second to 20 meters per second as it went around the roller coaster. We would be comfortable with the idea that this is a slowdown. Okay, it's a deceleration. Okay, the way we would calculate this is just be comfortable with the idea that this now is the start, and this is the end. Okay, plug it in the same way, but what you'll notice this time is that it's 20 minus 35. Okay, now let's just say that this took, let's just say this took 4 seconds. So we divide that by 4. The first thing to note is that you're going to end up with here, you're going to end up with a minus number because the one number is bigger than the other. Okay, so that's going to be minus 15 divided by 4. Okay, so this is what tells you straight away that this is a negative, a deceleration. Okay, so it's negative, so it's minus 3.75 meters per second square, and that means it's a deceleration. Okay, you may also need to rearrange the formula to make time the subject, for example, in which case what you would do is you would take, so if we just flip onto a fresh page, if you know that A is equal to the change divided by the time, then you could basically, if you wanted to know the time, you would just basically switch the acceleration and the time. So you could do the change divided by the acceleration to give you the time. Okay, so that's one rearrangement that you might be comfortable with, and you just need to maybe note that down. Okay, alternatively, if you are given A is equal to V take U over T, it's possible that you can make any of these other aspects the subject as well, and you just need to rearrange the formula to do so. Okay, so say you wanted to make V the subject, for example, you would move T over first, so A times T is equal to V take U. If you wanted to know the start velocity, for example, what you would then do is you would do V plus A times T, and that would tell you U. Okay, and that's just a quick kind of rearrangement that you might find useful as you do those questions. Okay, right, any issues at all, again, as usual, give me a shout, and we're going to end that video there.